everyone, I hope that I find each of you well. The next thing I want us to look at is using trig to solve slightly more complex problems than just a single right triangle. So for example, in this first case, we are being asked for x, and to find x, if we just say look at triangle A, we can look at triangle ACD here. Of course, since this is on a straight line, this is also going to be a right triangle. In order to find x, we could either find one of the acute angles in triangle ACD, so angle ACD or angle DAC. However, it doesn't seem that we have enough information to solve for one of those things. The other case is, if we knew AD, that side length, we could use Pythagoras to solve for x. Okay, so why don't we, just for the sake of it, let's call this side length y. And luckily we can solve for y using this right-hand triangle, triangle ABD. So let's say to find AD, which we've called y, we are just going to look at this right-hand triangle. So it's got a hypotenuse of 12. It has an acute angle of 25 degrees, and it's got side length y. At this point, we know that we have enough information to solve for y. The trig ratio that uses the opposite and the hypotenuse is sine. So we're going to use sine to solve for y. So sine of 25 is equal to the opposite, which is y, over the hypotenuse, which is 12. We can, at this point, cross multiply. So 12 times sine 25 is equal to y. You plug that into your calculator and you get that y is about 5.1. So we get that y over here is about 5.1 units. Now, to find x, we can look at this right-hand triangle, and I'm redrawing the triangles. It's not something that you have to do necessarily, but I think it helps simplify it a little bit to be able to break down the problem into smaller triangles instead of trying to look at it all at once. So if we just go back to the left-hand triangle, we have the hypotenuse is still 6, y we just solved for, which is 5.1, and then we can solve for x. So using Pythag, so this is step 1. 2. Using Pythag, we know that x squared, so this is the hypotenuse, right? The 6, because it's the longest side, and it's the side that's across from the right angle. So x squared plus 5.1 squared is equal to 6 squared. If we solve for x, we get that x squared is, well, it's 6 squared minus 5.1 squared. X squared is about 9.99, in fact. Take the square root, x is about 3.2 units. So that's the first example. Again, I know that I'm going through this moderately quickly. Make sure, take the time, pause, make sure that the individual steps make sense. Maybe do it, following along if you can. All right, next question. Find angle BAD in the right trapezoid below. So, all right, we've got this trapezoid. We're told that the height is 7. The length of the shorter side is also 7. And the length, or the base, you could say, and the length of the long base is 10. And we're asked for this angle here. That's denoted by a question mark. Why don't we call it, I don't like question marks, so why don't we just call it x? So Okay, we need to use what we know about this trapezoid in order to make, well, the name of the game is to have a right triangle, right? Because right trapezoids, we don't really know what to do with right triangles. We have skills now, right? We have the tools in order to find missing sides and angles of a right triangle. So why don't we draw this dotted line, this straight line down from the vertex B, make it a right triangle. I know that I've made a square, in fact, because I know that this height is the same as this height. It's going to be 7. This on the bottom, oops, since I've drawn it here, this side here is 7 up top. This side down here is also going to be 7. If from here to here is 7, and this whole length from D to A is 10, I know that this side here has to be 10 minus 7, or 3. So now, let's redraw the right triangle. Sorry, I'm kind of shaky. I got an angle X. I have a height 7. And I know now that this base, if you will, is 3. So now I have enough in order to solve for angle X. I'm going to have to use an inverse trig function. And which one do I use? Well, this is going to be the hypotenuse. This is going to be the adjacent side. This is going to be the opposite side. I have the opposite and adjacent, and I want the angle. Let's use tangent. So I know that tan X is opposite, which is 7, over adjacent. I know that X, therefore, is the inverse tan, so put that into your calculator, of 7 over 3. You do that and you get that X is 67 degrees. So therefore, therefore angle BAD is 67 degrees. All right, nice. That's example 2. I like to switch the colors, keeps things slightly more entertaining. Okay, next example. Find the area. So we have another trapezoid. This time it's not a right trapezoid, it's an isosceles trapezoid. And we're asked to find the area. So remember, the area of a trapezoid is, remember, the area of the shorter base plus the length of the shorter base plus the length of the bigger base. So remember, this is like, B. So it's little b plus big B divided by 2 times h. So here, I know that my little b is 12. My big B is 20, if we're comparing the two. H, I don't know. So H is what we're going to need to find. So we're going to do something similar as in the previous question. We're going to bring down this perpendicular line, perpendicular to AD. Let's do that on both sides. It's because we know it's isosceles, so these two sides are the same. Okay, I know that this triangle and this triangle is going to be the same, right, since it's isosceles. Soon we'll talk about congruent triangles and we'll be able to prove that, but for now we just know that those two triangles are going to be the same because it's an isosceles trapezoid. So now, I'm looking for the height here. Maybe I won't call it the height because you might confuse it with hypotenuse, so why don't we just call it x? So we want to find x. It would be helpful to know one of the other sides, so we could either look for the hypotenuse or the side here. This bottom side, this side that's adjacent to the 63-degree angle, actually is not too hard to find. So I know that this length from here to here is also going to be 12. This length from here to here, and this length from here to here needs to be the same. So I know that both of them together has to equal 20 minus 12, which is 8. So I know in order to add up to 20, each one has to be 8 over 2, or 4. Okay, so 12 plus 4 plus 4 is 20. So let's redraw this triangle. It's got a 63-degree angle. I want x. I know that the adjacent side is 4. I'm going to use tangent, right, since I don't know anything about the hypotenuse. So tan of 63 degrees is going to be equal to the opposite, which is x, over the adjacent, which is 4. X, therefore, is 4 times tan of 63. Put that in your calculator, you get, it's about 7.85 units. So now if we go back, so that's equal to the height also. So if we go back to, well, up here, I can find my area is going to be my small b, so 12, plus my big B, 20 over 2, times h, which I now know is 7.85. I plug that in my calculator and we'll round it a bit. It's about 126 units squared. All right, let's do one more question. So this question asks you to find the length of AD if ABC and ADC are right triangles. So looking for AD, let's call that X. So if we look just at triangle CAD with a 32-degree angle, it would be very helpful if I knew one of the other sides, right? If I knew either AC or CD, I could solve for AD. I don't know any of those sides, but I know that AC is shared between the two triangles. It's actually the hypotenuse of both of them. So why don't we call that Y? And now we're going to use triangle BAC to solve for that side. So let's do that first. Again, I'm going to redraw it. This side length is 10. This is 58 degrees. This is Y. Okay, so I have the adjacent side. I want to know the hypotenuse, so I'm going to use cosine. So let's use cosine. So cosine of 58 degrees is equal to the adjacent side, which is 10, over the hypotenuse, which is Y. We can do our cross multiplication. Y times cos 58 is equal to 10. Y is equal to 10 over cos 58. Plug that in your calculator, you get that it's 18.9 units. So I know that my Y here is going to be 18.9 units. Now let's redraw triangle CDA. So X is the side that we want. Our top angle is 32 degrees. The side length, the hypotenuse, is 18.9. So I want to use the trig ratio that involves the opposite side, which is X, and the hypotenuse, which is 18.9. Well, I probably use sine. So in this case, I'll use sine. So sine of 32 degrees is equal to opposite, which is x, over hypotenuse, which is 18.9. X therefore is, the product of 18.9 times sine of 32. Plug that in your calculator and you should get that x is 10 units. Good. So I've posted a worksheet. This worksheet is very, very, very similar to these problems. So if you were able to follow these, you should be okay for the other problems. Maybe go away and try to do the other ones. It'll be more or less from memory. And then if you need to, feel free to refer back to this video and submit it when you can.